Hi guys, and welcome back. Let's go ahead and explore the CoreDNS configuration by taking a look at the CoreDNS config map here in our Kubernetes cluster and seeing how it gets mounted into these CoreDNS pods. So we'll head over to our terminal here, and rather than looking for pods or deployments or replica sets, what we're going to look for is the config map resource. Now, you probably remember this command from the last video where we did kubectl get all. And when we run this command, if you take a look at the output, you can see that we get back a bunch of core types of resources in Kubernetes. So common things like pods or service controllers or daemon sets or deployment controllers and replica sets. However, what you can see here is that we don't have any config maps, and that's because the kubectl get all command, even though the name says get all, it doesn't actually get all types of resources. So if we were to run kubectl-API resources, this will show us all of the different supported resource types on the server, albeit they are not currently sorted by alphabetical name here. But if you scroll up a little bit and kind of look at the top of the result here, you can see that we do have a resource in the Kubernetes cluster called a config map. And this is just core to Kubernetes of pretty much any distribution. It's basically just a core resource type that allows you to define key value pairs in a config map and then mount that into a pod and then ultimately mount it into the containers within a pod as well. Now, when you're dealing with config map resources, you can also use the CM as an abbreviation for the config map resource type. So you don't actually have to type out config maps. You can also specify just CM as well. You also see that it belongs to the core API group here, which is just V1. It doesn't actually say core V1, but it is kind of implied that the name is core V1. And over here under the namespaced column, you can see it says true for config maps here. And what that means is that the config map resource, when you create one on your Kubernetes cluster, it must belong to a particular namespace. There are certain types of resources within Kubernetes that do not belong to a namespace, even though most of the core constructs that you're familiar with, like pods and deployments and replica sets and services and things like that, actually are tied to a specific namespace. But config maps are also tied to a specific namespace. But some of the things that are not tied to a specific namespace are things like namespaces themselves, right? It really wouldn't make sense to create a namespace within a namespace unless maybe some point in the future Kubernetes might support nested namespaces. I'm not sure if that's even something that's on their radar at the moment, but in theory, I guess you could do something like that, but for the time being, namespaces are not a namespaced resource. They are root level resources that apply to the entire cluster. The same thing is true for nodes here. So any node that has been joined as a worker into the cluster is a root level resource that does not belong to any specific namespace within Kubernetes. The same thing is true for things like persistent volumes as well, and a variety of other types of resources. But let's go ahead and skip over those, and we'll just focus on config maps for now. So what we're going to do is, instead of saying get all, we'll do kubectl namespace kubesystem, and then we'll say get cm, or you can say config map. And that's going to retrieve the config maps only from the namespace that we specified right here. And as you can see, there are a whole bunch of them right here. We've got ones related to the kube proxy, the Kubernetes root CA public key certificate. We've got the VPC resource controller, which is something that's specific to Amazon Web Services. And you can also see the number of data points that exists within each of these config maps right here. So this config map named extension API server authentication actually has 6 different key value pairs in it, whereas some of these other ones, like the CoreDNS, for example, only have 1 key value pair. So we could do a kubectl and then namespace kubesystem and say describe. So when we call get, that's just getting the high level resources without any details about them. But if we do describe config map, we can either just run this by itself, and that's going to describe all of the config maps on the kubesystem namespace, or we could specify the name of a specific config map that we want to get. So let's do a describe on CoreDNS. Now this is going to show us the entire configuration of the CoreDNS config map. And as you can see right down here, it's got a single key called the core file. And then the core file key contains a value right down here of the actual contents of our core file. So this is the default configuration, at least for Amazon Elastic Kubernetes Service. Of course, it's totally possible that other cloud vendors have a slightly different default configuration here, depending on what kind of customizations they might be applying. But what you're going to see here is that there is a listener here on port 53, which is your standard DNS port. And this is what's going to basically define the kind of root level server here. Now, CoreDNS can listen on other ports as well. You could certainly change from the default port to listen on an entirely different port. But in this particular case, the default configuration is just going to use DNS standards to listen on UDP and I think even TCP 53 in this case. Now the dot that you see right here might be a little bit confusing. It's not really obvious what that stands for. However, this is what you can think of as a DNS zone. So if you have a website like mycoolwebsite.dev or github.com or something like that, you can actually specify the name of the DNS zone that you want to have the CoreDNS server respond to. And then anything that is inside of these curly braces right here is going to be configuration for that specific zone on the listener port number that is specified right here. So everything inside the braces here, the curly braces, is going to be part of the configuration for any zone. So the period is indicative of any zone, not a specific domain, but it will literally respond to any incoming request into the CoreDNS server. So if I were to make a request for trevorsullivan.net or cbtnuggets.com or github.com, or pretty much any website out there, then the configuration that belongs to this kind of catch-all zone here is going to apply to that request. Now there's a bunch of different options that you're going to see down here, and one of them is actually a plugin. So CoreDNS is a plugin-based, they call it a plugin chaining-based DNS server, and that's because CoreDNS is extensible. You can use lots of different plugins to manipulate the responses that are sent from CoreDNS back to the clients, the pods that are actually making queries against the CoreDNS service. And one of those plugins right here that is provided by default to allow you to resolve internal cluster service names is called the Kubernetes plugin. So if we were to head over to the website for CoreDNS here, you'll see that there are plugins that are kind of in tree, so it's basically part of the CoreDNS project, but then you've also got these external plugins here as well. And if you would like to install or enable an external plugin, you're certainly more than welcome to do that. However, you'll notice that the plugins that are provided as external plugins are not actually supported by the CoreDNS team. However, the plugins that are included in tree for CoreDNS, these are part of the actual CoreDNS project, and in theory supported, at least to the best of their ability, as far as open source projects go, by the CoreDNS team. Now what you're going to see here under this list of in-tree plugins is they're alphabetically sorted here. So you can kind of look through the list and search for certain key terms. If you're using Microsoft Azure DNS, you could look for the Azure plugin, for example. If you're looking for configuring the local bindings for CoreDNS, you could use the bind plugin as well. If you want to enable DNS caching, there's actually a caching plugin right here. There's also support for Google Cloud DNS. And then there's also support for things like DNSSEC. If you want to do zone-based signing, you can actually enable the DNSSEC plugin in CoreDNS to support that capability to improve the security of your DNS server. Something else that I find actually really interesting here is this erratic plugin. And what's cool about this erratic plugin is that they actually intended this plugin for kind of testing unexpected network behaviors when clients are making queries. So if you have like dropped packets, or if you have delays, basically latency between the request and the response, you can actually introduce kind of arbitrary network failures and basically determine how your client application is going to respond in the event that packets are dropped, or if there's delays in the responses that are coming back from the DNS server. You can configure that using this erratic plugin. Now, something else that's interesting about the configuration of CoreDNS is that not only do you have this mechanism of plugin chaining where you can kind of feed a request through these different plugins, but if you want to have a single request actually be handled by multiple plugins, then you can use a feature known as the fall-through feature, and that allows you to basically say, well, I want, maybe the Azure plugin here to address a request. However, I want that request to not be returned directly to the client. I actually want it to fall through to another plugin. So you could say, well, maybe I want another plugin in my plugin chain that maybe forwards a DNS request to a different DNS server. And so you could actually chain these plugins together and use that fall-through feature to allow the requests to be processed by multiple plugins rather than just being responded to by the first plugin that returns a valid response. So CoreDNS is extremely flexible. These plugins provide you a lot of different functionality in terms of how you forward requests to other DNS servers, in terms of how you're actually responding to them. And of course, because it's plugin based, you can actually write your own plugins as well. And they've got a nice blog post here that kind of describes how you can create your own plugin and then chain your DNS requests to those different plugins. So what we're seeing here in the default configuration is that we're actually using this Kubernetes plugin here. So let's maybe find that over here in the list of plugins. So we've got K8s external. So this one would allow you to resolve load balancers and external IP addresses from outside of a cluster. But then there's the Kubernetes plugin here. And this is the one that allows you to read zone data directly from a Kubernetes cluster. And so essentially what's happening is when we make a request from a pod over into the CoreDNS server that's running as part of our cluster, then what's going to happen is Kubernetes itself is actually going to respond to certain types of queries that are going to cluster.local. So if the request goes to something.cluster.local, then that is going to be processed by the Kubernetes plugin here. However, if it's not addressed by the Kubernetes plugin, then you're going to see that we have a default forwarder here. And by default, any requests will be forwarded over to a DNS server that can be found in the pod's local etc resolve.conf file. And so that will help to ensure that any requests that are made to internal services are going to go to Kubernetes directly, but anything that does not match this plugin will then get forwarded externally from the cluster out to a root DNS server on the internet. And that will help to ensure that any requests for external resources like github.com, for example, are going to be processed as you would normally expect, as if you were hitting it maybe from a local web browser, for example. There's a bunch of other options in here as well. So there's caching being enabled here. There's also configuration reloading enabled in here. There's load balancing enabled. So there's a whole bunch of features, and you're also going to see this Prometheus endpoint here. So if you want to gather metrics about your CoreDNS deployment on Kubernetes, then this Prometheus endpoint is going to help you gather that information so that you can kind of monitor the health and performance of your CoreDNS deployment. So this is the config map for CoreDNS that's ultimately getting mounted into the CoreDNS pods and then mounted into the containers file system from the pod volume mount. So that's kind of how you can configure CoreDNS, and in the next video, we'll actually test out connectivity to CoreDNS and make sure that we are able to resolve against it. I hope this has been informative for you, and I'd like to thank you for viewing.